Today I'm going to talk about amniotic diversification during the Mesozoic era, and I'm really going to focus on the sauropsids. So as you go through this lecture today, here's some test questions that you're going to be responsible for. I'm going to make it easy. First one, describe the conditions of the Mesozoic that led to the rise of dinosaurs over the synapsids. Now if you remember, at the end of the Permian, the synapsids were dominant over the sauropsids. Okay, so you have this major extinction event, wipes out most of the dominant synapsids, you have a clean slate. This time, the archosaurs, which is a type of sauropsid, became to dominate the Earth. Why? What environmental conditions were occurring at that time, and what type of adaptations did they have that allowed the dinosaurs to become dominant over the synapsids? And second, were dinosaurs endothermic or ectothermic? I mean, for a long time, because they were reptiles, we considered them to be ectothermic. Is that true? So you'll need to choose whether they were endothermic or ectothermic and explain. And also, they may have been a little bit of both. That's also a valid answer as well. And then we know that dinosaurs went extinct about 66 million years ago. There's one prevailing theory explaining the extinction of the non-avian dinosaurs. There's also been other theories proposed as well. And recently, one of those has been kind of debunked more or less. And one of the other theories is now really taking root. And you need to know which one that is. So we know that amniotes include both the sauropsids. These are your lepidosaurs. Think lizards, snakes, testudines, which are the turtles, and archosaurs, which is this really amazing group that includes potentially turtles, but definitely crocodiles, pterosaurs, dinosaurs, and the birds, and of course the synapsids. And today we have the eutherians, which are your modern mammals, the marsupials, and the monotremes. But back in the Mesozoic, those were just, the ancestors were just getting started. Here is a phylogeny of amniotes, including both stem groups and crown groups. Remember, crown groups are still living today. Stem groups are the ones that are extinct. So a eutherian, like yourself and I, we're a crown group, whereas a dinosaur would be an extinct stem group. And I'll be honest, these phylogenies are being overturned, changed, modified every single year. So as our knowledge continues to grow, we revise these relationships all the time. Let's talk about the End Permian extinction, because this really plays into that first question. About 251 million years ago, a large area in modern-day Siberia began to experience massive amounts of volcanism, and this led to the greatest extinction event that we know of on the planet. In fact, it's called the Great Dying. And here's a map of the Siberian traps. And on the left is a picture of the Siberian traps, of all the volcanic activity or rock that was left over from that time period. This caused enormous changes to global ecosystems. First of all, we think that the End Permian was a 1-2 punch. You had massive volcanism that occurred rather quickly, spewing tons and tons of material into the atmosphere. That dropped temperatures very rapidly, and that first round of extinction events was probably caused by the drop in temperatures. Volcanism continued on for tens of thousands or even 100,000s of years. And as a result of continually spewing carbon dioxide into the atmosphere, temperatures spiked. So you had cooling, caused one round of extinction, then you had warming that caused another round of extinction. And because you're spewing out sulfates, carbon dioxide, this led to an acidification of the oceans, which also led to a massive extinction of over 90% of everything that lived in the oceans. So this was an incredible event that basically wiped out all the dominant synapsids on the planet. Also during this time, because you had massive collapse of global ecosystems, you had a lot less oxygen in the atmosphere. In the Permian, oxygen levels were high. And this is important because if you have high oxygen levels, life can be really energetic. But during the beginning of the Triassic, oxygen levels went from almost 30% of our atmosphere down to about 12%, 10%, 15%. We're not exactly sure, but it was cut in less than half. And what that would mean is, if you're standing at present day sea level with 12% oxygen, you might as well be standing almost 12,000 feet high in today's world, 22% oxygen. So that was hard for a lot of animals with two-way lungs to deal with. Well, at any rate, we entered the Mesozoic with the Triassic, which lasted from 251 million years ago to 199 million years ago. And we start to see the sauropsids diversify, including the archosaurs. They took to the land, to the sea, and the air. So we start getting pterosaurs, ichthyosaurs, and of course, the dinosaurs. Okay, so let's talk about the archosaurs. So the Triassic lasted from 251 million years ago to about 199 million years ago. And this is when this relatively minor group of reptiles began to diversify into things like the crocodilians, the pterosaurs, the dinosaurs, and eventually into birds. And I use the word pterosaur, that is correct. We usually hear the word pterodactyl. Pterodactyl is a genus of pterosaurs. So archosaur means ruling lizards, crocodilia, the non-avian dinosaurs, and of course the birds. What are the defining characters of archosaurs? I mean, what in the world relates a pterosaur to a crocodile, to a dinosaur, and a modern day bird? Well, let's take a look. First of all, the ancestors to all dinosaurs were called thecodonts, and this means they had teeth set in sockets. Now, if you think about like a shark, their teeth are in rows, right? And they're just a part of the skin, so they're easily shed. Think about you. We have our teeth set in our skull like the archosaurs did. They also have what's called a mandibular fenestra. Fenestra means window, and mandibular, mandible, think your jawbone. So they have this little tiny opening in their lower jaw, and that's called the mandibular fenestra, and we see that in all archosaur groups. And we're pretty certain they all had parental care as well. Birds today, of course, make their nests, and they care for their young. Alligators, they make a nest, they care for their young. So we're pretty certain the dinosaurs did it too. And we actually have fossil remains of dinosaur nests. They were quite large. Think the size of your bedroom or even larger. And we even have fossils of females, or at least a parent dinosaur, sitting on their eggs, guarding them. So we know that they had those characters, but there's also other potential characters, and these are important. All modern day birds have a four-chambered heart. So do mammals. There's a unique benefit to having a four-chambered heart. It allows you to be much, much more active than animals with three-chambered hearts. Think mammals and birds way more active than a lizard. And the reason why we can do that is because we separate the pulmonary route from the systemic route. That does several things. Very efficient at getting oxygen flow. Then we can create higher blood pressure, and that allows you to rapidly move blood to distant parts of the animal. Having a four-chambered heart also allows you to grow much larger as well. And of course, dinosaurs were among the largest animals that have ever lived on the land. It's also been hypothesized that dinosaurs may have had a one-way lung like birds. So we have a two-way lung as a mammal. You breathe in, the air goes into our lungs, and you breathe out, and it comes right back out. What that means is you exchange new air with old air. Now in birds, it passes through the lungs in one direction. That is much more efficient. If you're in the beginning of the Triassic and there's a lot less oxygen, having a one-way lung is much better than having a two-way lung. All right, let's talk about the dinosaurs. The first dinosaur showed up in the early Triassic around 233 million years ago. And of course, we all know that dinosaurs went extinct 65.5 million years ago, or to the present, considering the birds, right? We have described between 1,500 and 2,400 species of dinosaurs. Of course, that's a likely underestimate. Very few things actually fossilize. These things are around for 170 million years. Of course, there was more than 2,400 species of dinosaurs. It's just those are the ones that we found so far. The ancestor to all dinosaurs was bipedal. That means they walked on two legs. You and I were bipedal. We walk on two legs. So dinosaurs being erect, if you notice, they went from that lizard-like, where lizards have a sprawling gait, their legs are off to their side, but the dinosaurs evolved to have their legs up underneath them and walking on two legs, and that freed their lungs from their movement. Another way that dinosaurs could be more active. So we're starting to think, why did the dinosaurs become dominant? Well, I've already talked about this. One-way lungs, low oxygen. Can you start to make the connection here? With a one-way lung and a period of low oxygen, at this point, you're much more efficient at extracting oxygen from the atmosphere. That allows you to become more active compared to your synapsids, which have the two-way lung. And of course, dinosaurs, I love this depiction, it's kind of funny. They were bipedal, as I just said. This allowed them to free up their lungs and allowed them to become more active as well.